Welcome to The Explainer. Today we're jumping straight into a totally fascinating paradox in the AI world. We're going to look at how an apparent catastrophe, like a seemingly completely broken model, is actually turning out to be a groundbreaking research asset. It sounds crazy, right? But stick with me.
Let's start with a really jarring statistic, 54%. Now, in an industry where accuracy is literally everything, a 54% hallucination rate, that looks like an absolute obituary for a new AI model. I mean, it basically means the AI is just making things up more than half the time it speaks.
And this is exactly what happened when Grok 4.5 hit the leaderboards. The benchmark verdict came back, and man, it was a confusing mixed bag. It had the best tool use on the market, it ranked 4th overall on intelligence, but it was carrying this massive, glaring 54% hallucination rate. Critics obviously saw this, immediately filed it under failure, and called it a massive liability. But what if they were looking at it in entirely the wrong context?
This actually perfectly illustrates a pattern we've seen time and time again. History is literally littered with happy accidents where just changing the context turns a supposed malfunction into a brilliant superpower. Think back to 1928, when mold ruining a petri dish became penicillin, or 1945, when a melted chocolate bar next to a radar magnetron gave us the microwave, and of course, 1968, when a failed, incredibly weak glue became Post-it notes. The defect wasn't a failure at all. It was just being judged in the wrong context.
So bringing this back to AI, to understand why a 54% failure rate is actually a superpower, we first need to grasp how language models actually hallucinate. Because here's the crucial thing, they don't just hallucinate randomly. They're designed to produce the next most plausible thing, and they do it confidently and fluently. Think about the contrast here. If an AI generates a uniform random error about the capital of Australia, it might spit out obvious garbage, like Oslo. But a true hallucination? That's way different. It will confidently look you in the eye, so to speak, and tell you the capital is Sydney. It's fluent. Sydney is the largest city. It's an adjacent truth. It can so easily trick you because it doesn't sound broken at all. And this brings us to a massive, really tricky problem for AI safety researchers. How do you actually train a guardrail model, like a hallucination detector, to catch these smooth, convincing, adjacent lies? Well, to train a model to catch confident wrongness, you need massive volumes of confident wrongness to train it on.
The traditional methods completely fail us here. If you use human-generated data to train your guardrails, it's incredibly slow, it's expensive, and it's strictly bounded by human imagination. Okay, what about code-generated data? Well, if you use that, you just get uniformly random noise, like that Oslo example we just talked about. It completely lacks the real, textured pattern of a genuine AI hallucination.
So what's the actual solution? Production model synthetic data. The only thing out there that generates naturalistic, genuine wrongness is a production model that actually hallucinates at extremely high rates, like our 54% model. It produces real errors from its own internal world, complete with authentic training gaps and those confident leaps across uncertain terrain. Walk with me through this pipeline, because it's fascinating. Step 1. You take that broken, highly hallucinating model and run it at massive volume. Step 2. You save its output as raw, labeled data, usually formatted as massive JSON files. Step 3. You train a smaller, lightweight classifier model on that exact output. And finally, you deploy that classifier as your guard layer. Think about that for a second. You are literally using a broken model to teach a good model what broken looks like.
Now you might be wondering, hey, why can't we just ask a really smart, aligned model like Claude or ChatGPT to act wrong? Well, it comes down to a core truth. The hedge is the tell. When highly aligned models try to be wrong, their intense safety training essentially forces them to hedge. They'll say things like, well, I'm not certain, but they simply cannot perform pure, unadulterated, confident wrongness.
Because these well-aligned models were trained specifically to eliminate that confident wrongness, they've actually created a hard capability ceiling for themselves. You just cannot unalign a production model with a prompt. If you ask them to role-play making mistakes, you end up training a detector that catches acting, not real hallucinations. They are structurally incapable of providing the raw data researchers desperately need.
Which brings us to the incredible takeaway from this whole explainer. The exact defect the industry heavily criticized, that staggering 54% error rate, is the exact tool needed to build our AI defenses. The broken model hardened the reliable one. The defect itself literally became the curriculum.
So I'll leave you with this provocative thought to chew on. A benchmark position isn't destiny. It's really just a starting point to ask where a certain capability fits.
So look at your own projects, your teams, maybe even yourself. For what context is your worst failure profile actually your most valuable tool? How might your own defects be superpowers just waiting for the right lab? Thanks for joining me on this explainer today, and hey, always keep questioning the context.